This is one of the hardest volume questions on the June SAT, and you can't solve it until you know this trick. We have a cylindrical tank with a radius of 10 partially filled with water. So we have some sort of tank. We're going to pretend like this is a cylinder partially filled with water. Sphere with radius k is inserted into the tank, and then it increases the volume to a new amount by displacing the water. So what we need to find is the volume of the sphere to decide how many inches we're going to raise the cylinder. So what we can say is we can use what we're given to write some equations. We know that the volume of a cylinder is going to be pi r squared for the base times height for how tall it is. So we know that the volume that's going to be changing is going to be the amount of height that's changing times pi r squared, and we know that our r is 10. So to define what the volume of the sphere is, we're going to say height times 100 pi. So we know that the volume of a sphere is going to be 4/3 pi r cubed. Now in this case, we have 4/3 times pi times k as our radius, and then we're going to cube that to get the volume of this particular sphere. Now we know that to calculate what our change in volume is going to be, we're going to use this equation, h times 100 pi. And then once we solve for this h, we're going to be able to decide how much our volume actually changed. So from here, we can divide both sides by 100 pi, which will cancel here, and we'll be left with h equals 4/300 times k cubed. And we know that this equals 1/75 times k cubed, which is k cubed over 75. So we know that our answer choice is answer choice C.